Welcome to the Explainer. So, today we are looking at something that honestly sounds a bit like science fiction, but it's actively unfolding right now. We're going to see how heating up plain, ordinary dirt might actually be the missing piece to solving one of our biggest renewable energy problems. Get ready, because we're looking at a completely new era of energy storage.
To really get why this matters, we've got to talk about this number, 20%. The Australian energy market operator is predicting that by 2050, over 20% of renewable energy, stuff like wind and solar, will just be curtailed. That basically means turned off and wasted. Because, the wind blows and the sun shines when we don't necessarily need the power right at that exact second, meaning those massive turbines and solar arrays are simply stopped in their tracks. And right alongside that wasted clean power, we've got a second huge problem staring us in the face. Nearly half, 46% of all building energy demand in the US goes straight to heating, cooling, and ventilation. And the overwhelming majority of that massive 46% slice, it's powered by burning dirty fossil fuels. So we're literally throwing away clean energy on one hand while burning fossil fuels to stay warm on the other.
All right, so Section 1, the renewable energy storage crisis.
Because, look, despite all the incredible advancements we've made in renewables over the last decade or so, our infrastructure is still totally trapped in this high emissions cycle. Over 50% of new homes built in the US still rely on natural gas just for space and water heating. And on top of that, low-temperature industrial processes, things like drying food or making bricks, they add another 10% to the country's energy-related carbon emissions. We urgently need a way to bank clean energy so we can replace all that gas. Which brings us to Section 2, heat, the alternative to batteries. When we hear the word storage, our brains naturally jump straight to chemical batteries, like the lithium-ion ones in our phones or electric cars. But to solve a heating crisis, we kind of need to flip the script and shift our mindset from chemical electricity over to heat. And that brings us to thermal energy storage, or TES. This is simply the process of storing excess renewable energy as heat, rather than trying to convert it into chemical electricity for later use. Imagine harvesting the intense power of a windstorm or a blazing summer afternoon, and instead of cramming it into a traditional battery, you just bank it as pure concentrated heat to use when the winter freeze sets in.
Now, to be fair, TES isn't a brand new concept. Over in Berlin, a company named Vattenfall has actually built this massive 150-foot water tower. It's essentially a giant thermos. It takes excess wind energy from the grid, uses it to heat enough water to fill, get this, 350,000 bathtubs, and keeps that water at just under 100 degrees Celsius. But there's a big limitation here. Water boils at 100 degrees, right? So it literally can't get any hotter without turning to steam. And this specific tower only holds that heat for about 13 hours. So it's great for daily fluctuations, sure, but kind of useless for seasonal shifts.
So, Section 3, how does the sand battery work? Okay, here's where it gets really cool. The star of today's explainer is a Finnish startup called Polar Night Energy. They have successfully launched the world's first commercial sand battery. Located in the town of Kangenpää, Finland, this isn't just some prototype sitting in a lab. It is a fully active 23-foot-tall steel silo packed with 100 tons of low-grade sand. And it is currently hooked up to the local district heating network, actively keeping homes, offices, and even the municipal pool warm for 10,000 citizens right through the brutal, sunless Finnish winter. Let's break down exactly how this works, because it's honestly wonderfully simple. Step 1. When there's excess solar or wind power flooding the grid, that electricity goes in and powers a resistive heater. Step 2. That heater warms up air, which is then circulated through a network of pipes buried deep inside the silo. Step 3, the sand surrounding those pipes just absorbs all that heat. It relies entirely on resistive heating, which means it works exactly like that standard toaster sitting in your kitchen, just on an absolutely massive scale.
And right here is exactly why sand is the secret weapon. Remember how water completely maxes out at 100 degrees Celsius? Well, sand can reach a staggering 600 degrees Celsius. That's over 1,100 degrees Fahrenheit. And because the tank is highly insulated, it doesn't just hold on to this intense heat for a few hours. It can literally hold it for months. We're talking true seasonal storage here, banking the hot summer sun to use in the dead of winter.
Moving on to Section 4, sand versus lithium. When you put these technologies side by side, the contrast is pretty wild. Looking at sand batteries, they just require standard, easily available equipment, steel silos and steel pipes. They use cheap, recycled construction sand, which means absolutely no toxic mining. And since there are zero liquid electrolytes to degrade over time, they boast a lifespan of 50 years or even more. Compare that to lithium-ion. You've got a max lifespan of maybe 15 years, it relies on incredibly complex and controversial mining for stuff like lithium and cobalt, and it's full of degrading chemicals. Sand completely bypasses these massive supply chain and environmental headaches.
And because it's so scalable and sustainable, the environmental upside here is massive. According to an estimate by Mission Innovation, if we scale this up, this sand battery technology could avoid over 100 million tons of CO2 equivalent annually by the year 2030. Just to put that gigantic number into perspective for a second, that is roughly double the entire carbon output of New York City in the year 2020. That is huge.
But we need to be realistic. So, Section 5, Technology Limitations and Cost. As hyped as we can be about 600-degree sand, no tech is totally perfect, right? Here's the catch. We have to look at what engineers call round-trip efficiency, or RTE. If you use wind to heat the sand and then extract that heat directly to warm a building, the heat-to-heat efficiency is an incredible 99%. Resistive heating is basically perfectly efficient. But, and this is a big but, if you try to use that stored heat to generate steam to spin a turbine and get electricity back onto the grid, the efficiency absolutely plummets to a brutal 25%. Compare that to a standard lithium-ion battery, which gives you back 95% of the electricity you put into it. So the lesson here is crystal clear. Sand is brilliant for generating heat, but it's pretty terrible if you want your electricity back. Then, of course, we have the economic reality of scaling up. While dirt and steel are incredibly cheap raw materials, getting the actual price per kilowatt hour down requires massive scale. Polar Night Energy has a target cost of a highly competitive $10 per kilowatt hour, but they calculate they need to hit a 20 gigawatt hour scale just to achieve that. Their current flagship battery over in Finland, it only has a capacity of 8 megawatt hours. So they basically need to scale up their installations roughly 1,000 times just to hit that ideal market price. Which leads into Section 6, the right tool for the right job. So where does a giant superheated silo of sand actually fit into our world? It turns out there are plenty of places ready for this exact tech right now. The absolute best use cases are places that already have district heating pipelines. Any city like New York, Boston, or Denver that already pipes steam or hot water to its buildings can literally just swap out a dirty fossil fuel boiler for a sand battery. The same goes for large university campuses or industrial sites manufacturing steel and cement that desperately require intense, low-cost heat. The pipes are already in the ground, guys. They just need a cleaner heat source attached to them.
It really all comes down to this quote. It's all about choosing the right tool for the right job. Sand batteries are definitely not going to put lithium-ion out of business anytime soon, and they certainly aren't going to power your electric vehicle. But they perfectly fill this massive, dirty gap in our current energy grid. We don't need a single silver bullet to fight climate change. We just need a fully stocked toolbox full of diverse, innovative solutions.
Which leaves us with one final question to ponder today. Do you think the sand battery will succeed on a global scale? I mean, as the need for zero-carbon heating grows more and more desperate, could the solution really be as simple as heating up a silo of recycled construction sand? Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you next time.